Okay, let's jump right in to adding and subtracting functions. All right, so the way the notation is written for this is when you see something and it's written like this, f plus g of x, what they're saying is basically, hey, we're adding these two things together. And then when you think about it that way, right, it's, I mean, which is, you know, distributive property, right? That's kind of what you would get if you multiplied those out, even though they're all weird letters and everything. But we know how to do this. We've done this, right? We've added things together before that are polynomials, and we called it adding polynomials. But that's essentially what you're doing when you are adding functions, right? When you're composing them by using addition. So when we have something like this, basically, just write it out. Just go x squared minus 4, so that's your f of x, right? And then we are adding to that, we're adding g of x, and g of x is 2x plus 1. So this is what we've got, right? And so now what we'll do is we'll do what we did when we were working with polynomials, and we're going to just drop our parentheses, and then we're going to rearrange and collect like terms. So I can drop this one just really easy. I don't have to do anything to it because there's nothing happening or acting on the parentheses that we have to worry about. So this is where we're at. So we've got x squared, we've got 2x, right? And this is a different kind of term. And then we've got some constants here, right? So what we're going to do is we're just going to kind of combine what we can combine and just sort of go from there. So x squared is by itself, so that takes care of that. 2x is by itself, so that takes care of that. And then you got negative 4 and positive 1, which gives you negative 3. All right, so this is my new function. All right, so we would say that equals x squared plus 2x minus 3. And now for your domain is simply, are there any numbers that you can't put in this? And if you think about it, right, you could put anything in here and you'll get something back. And it's nice because everything works. And so the notation we're going to introduce you to for this, right, is set notation, right? And I'm gonna write it like this. I'm going to go d is equal to, and then we're going to use our brackets. And then we're going to go x, and then you're going to put a straight line down, okay? So it's like half of an absolute value bracket, right? And it has nothing to do with the absolute value, but that's what it looks like. So, and this is saying for all x, and then we would say x is all real numbers, and then we close off our brackets. And so that is the notation we want you guys to use and we want to expose you to, all right, is x all real numbers. Now you could just write all real numbers, but this is how you're going to see it, and it's how you may see it on the ACT. It's how you may see it in other things. So it's good to get exposed to that. And then for your range, the range is going to be written in the same way. We have to figure that out, right? We're going to write range, and we'll say y, but because we are dealing with functions, right? Instead of using y, we are going to use f of x. Right, or f plus g of x, but you know what, actually no, we're going to use y because it's just easier that way. And so now what we got to do is we're going to take this x squared plus 2x minus 3, and we're going to put this in our good friend Desmos. Okay, so let's do that. All right, I'm going to kind of shift this around a little bit, pull Desmos up. All right, and so I'm going to write in h of x equals, and we have x squared plus 2 of x, and you can see it kind of forming minus 3. And this is the new function that we have, and I'll just show you what I wrote here. I had both the functions listed here, right? But this is our new function that's created, right? And so if we zoomed out, right, or you'd be able to see that this thing just keeps going, right? It goes pretty high, right? But now for my range, though, we're looking at our y values, right? And so you'll hopefully also see that this thing never goes below -4. Right? -4 is as low as it goes. Now we could also find this using our axis of symmetry and then locating our vertex and dealing with the maximum and minimum of all that, right? But for right now, we're going to do it this way, right? Just using decimals. So you plug it in, you plug in your composed function, and away you go. And I know that this thing never goes lower than -4. So we are going to pull it up, and we will say the way we would write this, if it never goes less than that, we would say y is greater than or equal to -4, and then close that off. All right, and that's what it means, and it's that simple. Okay, so let's try another one. All right, so now we have f minus g of x. All right, so we have x squared minus 4 is our f of x. Sorry, I got to write this down because I don't remember anything. And our g of x, I believe, is 2x plus 1. There we go. Yep, sure is. All right, so if we're subtracting these, we're now going to go x squared minus 4, because that's f of x. Remember, this is the same thing as this, f of x minus g of x. It's like you're just using distributive property here. So x squared minus 4 minus, right? So this was my f of x. And then we're subtracting g of x, which is 2x plus 1. Now, this is very similar to what we just did, except that we now have a negative sign. And you have to remember that when you have a negative sign in front of a set of parentheses, you have to distribute that to all the terms in there. And so what it basically does is it makes everything the opposite of what it is. So instead of having positive 2x, we now have negative 2x. Instead of having positive 1, we have negative 1. All right, and now it's just a matter of rewriting this thing. And so when we rewrite it, we get x squared minus 2x minus 5. And that is what we get for f minus g of x. This is our new composed function. What we have, our domain, again, is going to be written in the same way, x. And then for all x, x is, we are going to say, all real numbers, right? All real numbers, okay? That's your x. Your range, I'm going to say y is, and now we're going to take this and we're going to put this in to Desmos and see what we get. Okay, so we got x squared minus 2x minus 5, all right? So let's get rid of this one. We're going to have a new function called j of x. Oh, we got weird, crazy things going on here. Equals x squared, and we got minus 2x. Minus 2x. You can see how that kind of changed it. And then minus 5, right? And so now it doesn't really look that different. It looks like it shifted over here, right? And now instead it looks like it comes down here, and at -6 is the lowest point it hits, meaning that it's going to be y is greater than or equal to -6, right? Because it'll never be lower than this. So let's go to our form. We'll say y is greater than or equal to -6. And that is how you write those and how you tackle these types of problems, okay? So using Desmos, we can figure all that out. All right, we'll see you in the next one.